welcome to this video on resistors in series and parallel calculations. Now let's consider this question given. It says find the total current flowing through the circuit. Alright, so we have a circuit network here of resistors both in series and in parallel, and then we have a 12-volt power supply here on the circuit, right? So the question is asking us to find the current flowing through the circuit. Now, in order to find the current flowing through the circuit, we have to first of all break down the circuit and find an equivalent resistance. Then when we obtain the equivalent resistance, we can now employ the Ohm's law to find the current flowing through the circuit. So our first task is to break this circuit into a single circuit to obtain an equivalent resistance. Alright, so let's start. Now, since this is a network of different resistors connected both in series and parallel, you have to be very careful when breaking this circuit, right? You have to be very careful when breaking these circuits. Now, from the source, this is the source, current flows from the source. So now the direction of current flow is from the negative terminal to the positive terminal, so it is moving up. So current is flowing in this direction. Now I'm going to be showing you a trick on how to break this network. Now this current flows through this resistor, passes and gets to this node. Now whenever it is at a branch, each branch can be called a node. Now when the current gets to this node, so let's say we have something like this, you have your current now in this direction. Now it gets to this node, some of the current flows through this other resistor. So I just want you to get this concept before we can continue. Some of the current flows across this resistor, whereas some flows inside here. Okay, once the current gets to this node, any junction at all is a node or a branch. Once the current gets to this node, some current flows through this resistor, whereas some flows here. Now when it gets to this other node here, then it means that some current will flow through this resistor, whereas some current will flow through this resistor. But now let's observe something. When it gets to this node, the current that flows through this resistor still flows and gets to this node, but at this node there is no other branch. Rather, that same current still continues flowing from here, then through this resistor before it comes out here. But when it came to this node, the current diverted. Some flows through this resistor, while some flows through this resistor. So that simply means that some that flows through this resistor also flows from here to this point and then through this resistor. So which means this resistor and this resistor are operating on the same current. So the 0.5 ohm resistor and this 0.5 ohm resistor still have the same current flowing through them, because once the current goes to this branch, some flow through this resistor. Now that same current that flowed through this resistor came out to this branch but came down, and then that same current enters into this resistor. So which means these two resistors are in series. Resistors are said to be in series when the same current flows through them, but they are said to be in parallel when different current flows through them. So these two resistors are what? In series, and which means we have to first of all resolve these two resistors in series. Then they are now in parallel with this one, because when the current came in here, it branched and then branched, flowing through two different resistors. So which means this is already in parallel with the result obtained from resolving these two in series. So I want you to keep this in mind, because that will be our base for all our to be breaking down this circuit. So when the same current flow through different resistors, those resistors are said to be in series. But when different current flows through different resistors, those resistors are said to be in parallel. So our first task now will be to break this, to resolve this circuit here, break the circuit here and resolve these two resistors in series. So if you do that, remember, resolving resistors in series simply means you're going to be adding their results, right? So we'll add their result and find an equivalent resistor. So for that two resistor, 0.5 ohm resistors, the equivalent resistor between them, C equivalent, since they are in series, and when they are in series, you simply what? Add their value. So you have 0.5 ohm plus 0.5 ohm. So this simply implies that the equivalent resistor for that two becomes what? 1 ohm. So this is just for these two resistors. If you do this, the circuit becomes, so you have a new circuit now. So let's redraw the new circuit and see. Alright, so having found the equivalent resistance to be 1 for that, these two 0.5 ohm resistors over here, then we have the circuit to look like this. So we've been able now to find the equivalent resistance between these two, and we have it to be what? 1 ohms. Now once again, if current flows and then gets to this branch and flows down here, observe that the current will split. Some will go and flow through this resistor, whereas some will flow through this resistor, which means these two resistors are in parallel. So you resolve these two in parallel. So whenever you're breaking circuit like this, always look for the easier ones to start with and start breaking them down. So we resolve these two resistors in parallel and find their equivalent resistance. Okay, so you recall that when resistors are connected in parallel, their equivalent resistance becomes reciprocal of one another. So we have 1 all over C equivalent for those two that are in parallel, and we have one is 2 ohms and the other one is 1, so you have 1 all over 2 plus 1 all over 1. So this simply implies 1 over C equivalent is going to be equal to, so this is 1 over 2 is 0.5 plus 1 over 1 remains 1. So this simply implies C equivalent, or 1 over C equivalent, is now going to be equal to 0.5 plus 1 is 1.5. So in order to make C equivalent subject, you send C equivalent up, bring down 1. That means you simply take the reciprocal of 1.5, right? So this simply implies that C equivalent is now going to be equal to 1 divides 1.5, and that is going to be equal to approximately 0.67. So you have 0.67 ohms. Okay, so that becomes the equivalent resistance between these two when resolved in parallel. So the circuit will now have a different look. So let's see what it looks like. So after resolving these two resistors in parallel, we found the equivalent resistance to be 0.67. So the circuit breaks down to this. So we have now a single line circuit here, 0.67. So it's now easier. We can now resolve now between this and this. So observe, if current is flowing from the source through this resistor and flows and gets to this node, what happens is that some of that current flows into this resistor while some flows into this resistor. So which means these two resistors are what? Parallel to each other. These two resistors are parallel to each other, so we can simply resolve them into one resistor. So you remember the law? When they are parallel, then 1 all over C equivalent is now going to be a reciprocal of each of them. So we have 1 divides 0.67 plus 1 all over 2. So this is going to be equal to, or this simply implies 1 over C equivalent is going to be equal to, so let's obtain 1 over 0.67 plus 1 over 0.2 plus 1 over 2, please. So this simply gives us approximately 1.99. So we have 1.99. Therefore, if you make C equivalent subject, it becomes 1 all over 1.99. So this simply implies that the equivalent resistance between that two becomes 1 divides 1.99, and that simply gives us 0.50 ohms approximately. So the equivalent resistance between that two is simply 0.5 ohms. So having resolved these two now, these two in parallel, the circuit will now take a different shape. Let's see what it will look like. So after resolving these two resistors in parallel, the circuit becomes this. So this becomes the equivalent resistance we obtained, 0.5. Now if current flows just as we have been explaining and gets to this node, some of this current branches here, whereas some of this current goes here and gets to this node. Now some branches here and some goes this way. Now the ones that branches here gets to this node, some branches here and then some goes here, and then some goes here. Now the current that comes here, some flows from here and flows through this resistor, whereas some of the current flows over here and flows through this resistor. So which means these two resistors are parallel to one another because they are having different current flowing through them. So once the current comes down, some moves here and flows through this resistor, whereas some moves here and flows through this resistor. So these two are simply in parallel. So we resolve these two in parallel. So remember the technique. When resolving in parallel, simply 1 all over C equivalent is now going to be equal to 1 all over 1 plus 1 all over 0.5. Okay, so this simply implies that 1 over C equivalent is equal to 1 over 1 is 1 plus 1 over 0.5 is actually 2, and this actually gives us what? 3. So this simply implies to find the equivalent resistance, you take the reciprocal of 3, that becomes 1 all over 3, and 1 over 3 is simply equal to 0.3 ohms. So you have 0.3 ohms. So between these two resistors, the equivalent resistance is what? 0.3 ohms. So we'll further break the circuit and it will have a new loop. So let's see what it looks like. Alright, so after resolving these two resistors in parallel, we obtain 0.3 ohms. So this is now the equivalent resistor, 0.3 ohms. Now we need to further break the circuit. Again, if current is flowing through and gets to this node, some of that current flows through this resistor, while some is branched here and some flows through this resistor and then some is branched here. So this means that the current flowing through this resistor and this resistor is different. So that means these two resistors are what? In parallel connection. So since they're in parallel connection, you can easily resolve these two parallel. So we find the equivalent resistance between these two. Once again, 1 all over C equivalent is going to now be equal to 1 all over, the first resistor there is 1, so 1 over 1 plus 1 all over 0.5. So this implies 1 all over C equivalent is going to be equal to 1 over 1 is 1 plus 1 over 0.5 is 2. This is actually what? 3. So once again, you're going to have your equivalent resistance to become 1 over 3, which is 0.3 ohms. So the equivalent resistance between these two resistors is simply what? 0.3 ohms. Now the circuit will take a different diagram. So let's see what it looks like. Alright, so after resolving these two resistors in parallel, we found their equivalent resistance to be 0.3 ohms, and as can be seen, this is 0.3 ohm, which is the equivalent resistance between these two resistors. Now the circuit is looking quite easier. Now you observe that if a current flows and gets to this branch, some of that current will branch here, whereas some will flow through this resistor. But when it gets to this branch, there is no other place for the current to flow other than flowing into this resistor. So which means the same current is flowing through this 0.3 ohm resistor and this 0.5 ohm resistor. So which means these two resistors are simply in what? They are simply in series. So we resolve these two in series. Okay, and once again, to resolve in series, you simply what? Add. So equivalent resistance becomes 0.3 ohms plus 0.5 ohms, and that is simply going to be 0.8 ohm resistance. Okay, so that means the equivalent resistance between these two is 0.8 ohms. Now the circuit will take a different diagram once again. So let's see what it looks like. Now after resolving these two resistors in series, the equivalent is simply 0.8, which can be seen here. Now this circuit is looking very much simplified. So if a current flows from the source through this resistor and gets to this node, then some branches over here, whereas some goes here, some branches here, some goes here, and then branches here. So which means these four resistors that is remaining now are actually what? Parallel to one another, because the current flowing through them are different. So we have the four of them now parallel connected. So we can now employ the equation for parallel connection to solve. So for the 4 of them, we'll have 1 all over C equivalent. This is going to be equal to 1 all over 1 plus 1 over 0.5 plus 1 all over 0.3 plus 1 over 0.8. Okay, so 1 over C equivalent is now going to be equal to, so let's find all this sum just to save time. 1 over 1 is 1 plus 1 divides 0.5 plus 1 divides 0.3 plus 1 divides 0.8. So this gives me 7.58 approximately. Therefore, in order to find the equivalent resistance, we take the reciprocal 1 all over 7.58. So this simply implies that the equivalent resistance is going to be equal to 1 divided 7.58, and that simply gives us approximately 0.13 ohms. So you have 0.13 ohms. Okay, so this becomes the equivalent overall equivalent resistance of that circuit. So having found the equivalent resistance, oh sorry guys, so I've been using C for resistance, so just do well to replace C with R. This is just like the end of the video. I'm so sorry for that error, but I'm very much sure you understood everything I've been doing. It's basically the same thing, so you can simply say R equivalent instead of C, please. So for all these C's we've used, just replace them with R. So the overall equivalent resistance is simply 0.13 ohms, and the question is saying we should find the current flowing through the circuit. Remember, we have our source voltage is equal to 12 volts. So from Ohm's law, you recall that V is equal to IR, so which means you make the current subject, that becomes V all over R. Therefore, the current flowing through that circuit becomes V, being our potential difference is 12, R is 0.13. So this implies that the current flowing through the circuit is going to be equal to 12 divided 0.13. That gives us 92.3 ampere of current is flowing through that resistor, is flowing through that circuit, so 92.31 amp. So this is the amount of current flowing through that entire circuit. So that is how to break circuit diagrams with a very easy step. That's how you break circuit diagram when you have complicated circuit like that. Okay, that's how you break it. So in the next video, we are going to be looking into capacitors in series and parallel calculations. Then we are going to be considering a network like this to break down under capacitors in series and parallel. I'm sure you want to be a part of that video, so do well to hit the subscribe button and turn on your notification bell so you don't miss out on that video when it drops. Just in case you're new to the channel, do well to like our videos, comment nicely, share to your friends, and I will see you in the next video. Cheers.